Hi, my name is Dao Tuan Anh, and this is my stage 2 presentation for CSP 450. I'm working in Port B with my partner Matthew. In this stage 2, our job was to take the three virtual machines we built in stage 1 and connect them into a working network so they can talk to each other with the internet and communicate with other student network across the classroom. Next is stage 2 overview. So what is stage 2 all about? In stage 1, we built three separate VM, a client, a server, and a router. But they were just sitting there disconnected, turn up it like building three stores in different parts of city, but not building any road between them. Stage 2 is where we build those roads. We connected everything through physical network switches, set up a system called OSPF, so device can automatically discover route to each other, kind of like how your GPS find the path to the destination without you manually entering every turn. We also make sure that the only way to reach the internet is through our router. Add a firewall to control what traffic is allowed, and set up a secure remote access using encryption key instead of password. Next is the network diagram. Here's a picture of our network. Let me walk you through it. At the bottom, we have our client and server. The client is like an employee workstation, and the servers hold a company data and website. This connect to switch 4 with its symbol layer 2 switch. Switch 4 connect up to switch 3 through a trunk port. Switch 3 is the brand of the operation. It's a layer 3 switch, which means it cannot only pass the traffic, but it can actually make routing decisions. It hands out IP addresses to DHCP, manage traffic between VLANs, run OSPF to exchange routes, and has a dedicated route port to connect to each student router. Then we have our router. The router is only device that can connect to the campus internet. It's like the front door of the building. Everything going in or out passes through it. It's also translate our private addresses to public one using NAT. We use VLAN to separate my traffic from my partner traffic on the same physical switches. My devices are on VLAN 83 and my partner are on VLAN 76, as I have in two separate departments in the same office building. It with the old private network, even though they share the same switches. Next is how the network works, the traffic flow. Let me show you how data actually travel in our network. Saying the client wants to open YouTube. First, the client boot up. It doesn't have any IP address yet. It sends out a broadcast saying, can someone give me an IP address? Then request goes to switch 4, which just forward it along up the trunk to switch 3. Switch 3 run the HTTP, which is like the receptionist assigning office number. It gives the client an address. Now the client wants to read YouTube. It sends a request to switch 3 gateway. The VLAN 83 interface on switch 3. Switch 3 look at its routing table, seeing the traffic need to go to the internet and forward it to our router to a dedicated route port. The router take that traffic, swap out the client private address for the router campus. For the router campus address using that, YouTube respond. The router translate it back and deliver it all the way down to client. Next is a layer 3 switch. Layer 3 is the core of our network. It's the layer 3 switch. Layer 3 means it doesn't just forward traffic blindly like a basic switch. It can actually look at the IP addresses and making routing decisions similar to how a router works. On switch 3, we config two VLAN, VLAN 76 for my partner network and VLAN 83 for mine. Each VLAN has its own IP interface called an SVI. My VLAN 83 SVI acts as a default gateway for my client and server. My partner is the same as mine. So even though both VLAN exist on the same physical switch, they are completely separate networks. Switch trees also run to the XTP pool, one for each VLAN. My pool handout addresses for dynamic client, and it has a static reservation that always gives my server the address based on its MAC address. Then there's OSPF. Switch tree run OSPF to exchange route with both my router and my partner router to a dedicated route port, connect to my router and connect to my partner. This is how the network learns path automatically. And finally, we got a trunk port connecting down to switch 4, carrying both VLANs so the layer 2 switch can extend the network to additional access port. Next is switch 4 router configuration. Switch 4 is a layer 2 switch. Layer 2 means it only understands physical MAC addresses, not IP addresses. It cannot make routing decisions. I configure it with the same two VLAN, 76 and 83, with access port assigning 8 port to specific VLAN, and also a trunk port that carry both VLAN up to switch 3. The router had, sorry, the router had two network interface ENS33 facing the campus internet, getting a public IP via the DHCP, and ENS37 facing our internal network. I config NF table as the firewall. It acts like a security guard. Internal traffic going out to the internet is allowed, but the random traffic from the internet trying to come in was blocked. Only return traffic from connection we are already started get through, and it run that we swap our private addresses for the router public address on the way out. I also set up FRR with OSPF so the router automatically set routes with switch tree and learn all the student ranges. Next is the security setup. For the security, we set up SSH key authentication. I can log into a server and router from the client using an encrypted key instead of a password. To run this work, we created a test user called SSH test on the server. If you try to SSH as a SSH test, it gets rejected because there's no key for that user and passwords are completely turned up. The firewalls on the router control the traffic is allowed. Our internal network can read the internet freely, but the only traffic allowed back in is return traffic from connection we already started. It's like a security guard who let employee work out or come back in, but won't let a stranger walk in. Next is the result and demonstration. So does all work? Yes, the client gets its IP automatically every time from the switch tree DHCP. We can trace route from the client to YouTube and see the exact path to switch tree to the router, then out to the campus internet. That's proof every layer is working correctly. OSPF is working the router from neighbor relationship with switch tree and route from other student network appear in our routing table automatically. Both switches are verified. Switch 3 so both VLAN, both DHCP pool, OSPF route, and all routed port. Switch 4 so both VLAN and a trunk carrying traffic to switch 3. SSH key login work without password, and the file was filtering correctly. Finally, the challenges and lesson learned. The most challenge was understand layer 2 and layer 3. Switch 3 does routing. They actually OSPF switch for just forward frames, but configuring both of them on the physical Aruba hardware was tough. Getting the VLAN trunk port, routed port, and OSPF all working together take careful step-by-step work. My biggest lesson from stage 2 is understand the full traffic flow before you start typing command. One, I could trade a path from client all the way to the internet and back to both switches and router. Every command makes sense, but because I knew exactly what it was doing and why. And that's everything. Thank you for your attention.